Hello friends, today we will be discussing the European Rail Traffic Management System, commonly known as ERTMS. This lecture focuses on how modern high-speed railway signaling and control systems work and why ERTMS has become essential for the future of rail transport. Let us begin with a little history. Rail transport has been a vital means of long distance travel since 1830. Starting with the first railway line between Liverpool and Manchester. For many decades, rail served both passengers and freight extremely well. However, more recently, aviation has grown rapidly, offering cheaper and faster travel due to intense competition. As a result, rail, especially in Europe, has been pushed into a secondary role. Shift in transport preference. The main reason for this shift is the reduction in air travel costs. Budget airlines, high competition, and increased flight availability made flying more attractive. Railways, on the other hand, faced challenges in maintaining their market share. To remain competitive, the rail system needed modernization, faster speeds, and improved cross-border operations. The main problem in European rail. One of the biggest challenges in European rail is the lack of uniformity. Across Europe, more than 20 different signaling and train control systems are in use. This means that when trains cross borders, they often need to change locomotives, change drivers, or even change entire train sets. This increases travel time and reduces efficiency. A unified signaling system was urgently required for true European interoperability. Birth of ERTMS. To address these challenges, the ERTMS project was launched in 1989. Its purpose was to create a standardized European system for signaling and traffic management. Later, in 1998, the Signaling Industry Group, UNISIG, was formed to develop and finalize the technical specifications. Thus, ERTMS became a collaborative European initiative to modernize and standardize railway operations. Objectives of ERTMS. ERTMS has several key objectives. First, it aims to increase the competitiveness of rail compared to other modes like air or road. Second, it seems to improve interoperability, meaning trains should run seamlessly across countries. Third, it aims to improve safety levels through advanced digital systems. Fourth, ERTMS supports higher operating speeds, reducing journey times. And finally, it helps increase line capacity by reducing the spacing or interval between trains safely. Importance of ERTMS. Because of these benefits, ERTMS is now viewed as absolutely essential for the future of European rail transport. By providing safer, faster and more efficient operations, it helps railways compete globally. ERTMS is the technologically backbone enabling the unified European railway network. Objectives of this video course. The objective of this course and of our lecture today is to provide a detailed understanding of the ERTMS system. We will examine its regulatory background, operational principles, and technical architecture. Since ERTMS is particularly important in high-speed rail, we will also touch upon its applications in modern high-speed networks. Structure of this course. The content of this lecture is organized into several chapters, starting from basic railway safety concepts and then moving deeper into signaling and communication systems and the technical details of ERTMS. Chapter 1, Railway Safety. We begin with railway safety. Traditional railway systems relied heavily on trackside signals, physical lights placed along the track. These systems have limitations, especially at high speed, because drivers may not have enough reaction time or visibility. As the trains became faster, in-cab signaling emerged as a crucial solution. In-cab signaling brings signal information directly into the driver's cab, increasing safety and operational reliability. Chapter 2, Signaling and Monitoring Systems. Next we look at the different signaling systems used across Europe and Spain. Every country historically developed its own system, such as ASFA in Spain, LZB in Germany, and TVM in France. While these systems work well locally, they create significant challenges for international train travel. This fragmentation is one of the main reasons ERTMS was introduced, to unify these different systems under a single European standard. Chapter 3, ERTMS, a common system. This is the most detailed part of this course. Here, we will discuss the complete architecture of ERTMS, including its background and evolution, the regulatory framework set by European authorities, the three levels of ERTMS, Level 1, Level 2 and Level 3. Technical components such as ballast, the onboard ETCS unit, radio block centers and more. We will explore how these systems interact to ensure safe and efficient train movement. Chapter 4, Communication. Communication is one of the pillars of ERTMS. ERTMS relies on GSM-R, which stands for Global System for Mobile Communications Railway. It is a specialized version of GSM used exclusively by railways for safe communication between trains and infrastructure. We will also look at how ERTMS uses continuous data exchange to maintain safe train separation and provide movement authorities. Chapter 5, Lines equipped with ERTMS. ERTMS is not just a theoretical system. It is already in use worldwide. We will examine the evolution from early pilot tests to fully operational high-speed lines. Countries like Spain, Italy, France, and even several nations outside Europe have successfully implemented ERTMS on high-speed and conventional lines. This chapter demonstrates the growing global adoption of the system. Chapter 6, Future of ERTMS. Looking to the future, the next major milestone is ERTMS Level 3, which promises even more efficiency through moving block technology. We will also briefly discuss The shift from GSM-R to the newer FRMCS, the Future Railway Mobile Communication System. ERTMS continues to evolve and is expected to be the backbone of automated and digital railways in the coming decades. To conclude, ERTMS represents a major step forward in modernizing European rail transport. It improves safety, reduces travel time, increases capacity, and enables true cross-border interoperability. As the system continues to evolve, it will play a key role in the future of global rail transportation. Okay, thank you.